yesterday's session was basically focused on why are we learning this course? What is the need of having this particular team and this particular tool to take care of? Okay, why do we need a DevOps team or an SRE team? What are roles and responsibilities generally in a company or as an as a team on a whole? So today we'll be learning a bit about infra. What exactly is infra? Because there are people who are from other backgrounds. So I want to start with learning what an infrastructure is, and then we'll talk about cloud technologies, and then we'll start with AWS. Okay, so we'll not be covering everything today. So today's session will only be focused on understanding what exactly an infrastructure means. Okay, and what is cloud, how was it done before, and what is done now. Okay, so what do you mean by infra? Anyone wants to like share their ideas? Okay, so generally, in general sense, when we talk about infrastructure, we talk about like when we talk about building infrastructure, it means that there is an actual building or a tower or an apartment, okay, where you live. Okay, that is a physical infrastructure where we go ahead, live, and have our colonies or societies in. Okay, that is one infrastructure, but this is not same. Okay, we call it infrastructure because this is where our code resides. Okay, so home where you live is also called infrastructure. Home where your code lives is also called infrastructure. Okay, when you live, you don't just call your home as infrastructure. Infrastructure also includes your garden, your play area, playground, everything, right? In code terms, okay, where your code resides, where data resides, everything includes an infrastructure. Okay, now let me give you an example. When you go ahead and click on google.com, okay, that request actually goes to a server, a Google server, which will go ahead, process that request and send it back to you. Correct? Something that like that must have happened. So example,
Yes.
if I'm writing xyz.com, okay, it will go to a machine, okay, which is listed somewhere. Okay, I'll tell you more about where it is listed and what that IP means, what that domain means in some time, like in upcoming sessions. But you can just consider that every domain or everything that you write, like google.com, is pointed to an IP. Okay, now whenever you type that domain on your machine, it will go to a IP. That IP will process that request. That IP will have a code running in it. It will process that request and send it back to you. Okay, so now since it is going to an IP and where your code resides, it will go ahead, process the request and come back. So this IP is of a system or of a machine. Okay, it is basically of a load balancer, but for simpler terms. Okay, because we have an audience here who doesn't understand a load balancer currently and other tool chain, so let's forget about a load balancer and other things. We'll only discuss about a machine. So very simple. Google.com, going to a server. Okay, a server where your code is running, your code will process the request and send it back. So this server is basically your infrastructure. Okay, now when we call server, it means a machine. Okay, it can be a Linux machine, it can be a Windows machine, Mac machine, any machine. Okay, generally it is always Linux machines because they have like uh, they are lighter, and as for servers we don't need a lot of UI, so we don't want to spend a lot of our processing, our RAMs and CPUs, memories and all of that in in a UI that we won't be using. Okay, so that's why we generally use a Linux system, which is kind of more optimized usage of your server uh, than in terms of a Windows or a Mac system. Now, do you understand now? Like a server is going to be just a system. Okay, it is going to be your system, my system. It can be any system. Okay, that system can be in a data center. That system can be kept in a server room. That system can be on cloud anywhere. Okay, it's just that that IP as a public IP is attached to that system. That public IP is assigned to this particular domain. As soon as you go ahead and reach that reach that machine through that public IP, there is a process that's running there which is going to serve your request. Okay, now earlier there was something called as a monolithic architecture, wherein there used to be only one code for your entire application, which means one code for entire Google. Okay, one code serving everything. But then later on we realized that there is a lot of like, since our coding stuff is increasing, our requirements are increasing. Yesterday we understood that because we are in fast changing world, we want, like, our customers want some fast improvement in features, some fast new features being released quickly. So in a single code where everything is written, okay, so many team collaborating there becomes difficult. Example, you have one house, okay, and 100 people are living in that. You have one big house, big one, okay, and 100 people are living in that. Managing that house is going to be really difficult, right? Because everyone will have their own requirements, everyone will be doing something or the other, and it's going to be a havoc there. So better, instead of having one big house that is a monolithic architecture, let's bifurcate it in small fragments. Okay, every house or every component is actually serving a purpose. Example, if I have written a small code, that code might be just for payments. So this is going to handle all the payment related requests. So my request will come to one machine. One machine will then pass it on to, since it is a payment request, it will pass it on to some other machine that is solving all the payments part. One is solving all the account related login details. Another one is all the checkout, cart related details. So what I have done is I have different servers, okay, and I have different code. That code is specifically assigned to do a task. Okay, like that's how it is done in an efficient architecture. Like, if you have 100 people, all of them are working on a same thing, it's going to become difficult because somebody is writing something else, somebody is writing something else, and integrating everything is going to become difficult. Okay, that's how it happens when you have a big house and hundreds of people living there. Okay, but when you have a small subset of people, okay, that's why we have in India so many states and all. Okay, because India is a very big country, so one system or few people managing everything is going to become difficult, right? So for that we have kind of bifurcated it in states. Every state is handling their own people. Now state level is also very big, so we have smaller levels, like um, your own representatives. Okay, those will handle their area, their small area. Example, in Rajasthan there's going to be someone assigned for this particular area, someone assigned for this area, this area, this area. So smaller the problem, easier it is to handle. Okay, so that's how we have done. Instead of doing a very big monolithic architecture where like that particular code is handling everything for you, We bifurcate it into small segments, and small segment of code is called microservices. Okay, every microservice, like, it is created with a thought that this particular microservice is going to take care of this particular activity. Okay, like, this particular person is going to, like, your CM is going to handle your state. Okay, so PM cannot go everywhere and handle everything. So there are CMs are going to handle their own states. Below CMs, there are individual people who are handling separate sections. Like, there's going to be education people, there's going to be education minister, there's going to be other domains as well, finance and all of that. So they are handling their own part. Correct? So it's just not PM which is holding everything. It's different people handling separate segments. Those are called microservices. So this architecture is called as a microservice architecture. Okay. So now we have, when we started, like, initially when we started writing the code, as in back in some previous days, it was all monolithic where everything is written in one single code. But then we thought that it's growing rapidly. Okay. So since it is growing rapidly, it's better to have multiple segments taking care of single stuff. Now, earlier our architecture was easy, our infra was easy, as in there's one domain, one IP, everything is handled by that IP, because there's that code that's handling everything. Now it's not like that. There are different codes that are handling different stuff. Okay, we cannot put all of them in one machine. So we'll have multiple machines. Okay, 100, like 10, 20, 100, whatever set of machines we need. Okay, we'll have these many machines. All of these machines will have some or the other code running. We cannot have one domain pointing to everything. So we'll have one domain, like as in google.com, whatever you're writing on your browser, google.com, facebook.com, anything that you're writing on your browser is a domain. That domain is actually pointing to an IP. That IP will read what request you want to do, what you want to do here. What are you trying to do? Trying to check out, or you're trying to do you're trying to do some payments, you're trying to select a product. Whatever you're trying to do will redirect this request to a particular other machine where your code is running for handling that. Example, it's payments. You are going to write amazon.com/card checkout or something. Okay, that will be pointed to one machine. That machine will route it to the checkout service or a checkout or a payment service which is running on another machine. That will process your request, send it back to this main system. This main system will send it back to your client, or from here directly to the client. Okay. Now, since there are more microservices, there are more servers that are needed. Now, you didn't ask me one question, that why don't we put all of these services on one server? Right? We can't do that. It means that all of them are sitting in the same house again. Okay, so that house is gone, everything is gone. Okay, plus you need a bigger capacity. Like, you need a mahal to settle 100 people in that mahal, right? So better to have separate small houses. Okay, every house is handling a specific activity, a specific task. Okay, and let them take care of it. Okay. Am I making any sense? Any questions still here? Now you guys understand what an infrastructure is. And infrastructure is all of this, like all these servers that I'm talking about here. Okay, servers, databases, everything. This is your infra, where your code lives. Okay, am I making any sense? Okay, so your domain is pointed to an IP. That IP is a machine. That machine has the code might redirect it to another code, which is again running on which is again running on another IP. That's another host, host or a server, okay, or a machine, okay, where your code resides. That might be pointing to another machine. So all of this is part of an infrastructure. Okay, this infrastructure I'm talking about, all of these are machines. Okay, now these machines can be, as I already mentioned, kept anywhere. It can be on a data center, it can be on cloud, it can be your machine, my machine, any machine which has a public IP. Now I am again pointing out to public IP because it needs to be publicly available, right? If you have a private house, nobody is going to actually go ahead and be able to visit that. Okay, example, um you are having an auction, but it is a private auction. Okay, you are having an auction of maybe a painting. Okay, but it's a private auction, which means only limited people are allowed. Okay, same way, in a private IP or in a private environment, only private people or internal people are allowed to access that. Okay, but when we talk about a public auction, that's when we are talking about public audience, like a wider audience, and everyone is allowed to come there and participate in the auction part. Okay, same way, in a private IP, only some few audience will be able to access that particular resource. Okay, while in a public IP system, okay, anyone can go ahead and from their browser reach that particular IP. There are some restrictions, you can put restrictions and all of that, forget about that, those things, but in a general sense I'm saying. So if you and me, are we working in Facebook, or we are have anywhere related to Facebook? No, but we can still access Facebook, which means that it is running or it has a public IP assigned to it. Okay, which means it is open to public now. Okay, um do you want some more examples for this? I'll give you one last example for public and private. Again, when you talk about a private organization, okay, a private organization is where only limited people are involved. There is a board, there is a specific board, an internal board members. Only specific people are actually stakeholders of that particular organization. But when you talk about a public organization, okay, it is publicly listed, and now you and me can go ahead and buy shares for that particular company. A private company, you and me cannot go ahead and directly buy until and unless we are allowed to by the founders or founding members of that organization. Okay, but when we talk about a public organization, you and me, whether we know our whatever stocks we buy, do our founders even know us? No. If you go ahead and buy a stock of Reliance tomorrow, that doesn't mean Ambani will know us. We are shareholders, but it's a publicly listed company, so we can go ahead and buy a share. It's there for sale. So public and private. Public IP, private IP. IP is basically a particular address that's given to a machine. Okay, and why do we need a domain then? We need a domain because we want to understand the name. Now example, if my name becomes um, something like on the day, timestamp, and everything that I'm born in, it's very difficult to remember that then, right? So suppose you call me with my company's employee ID, okay, then it becomes difficult for you, because if you have to remember 10 people's name, that means you want to remember 10 employee IDs unnecessarily. If you have hundreds of people, then you have to remember hundreds of IPs. So we kind of remember something that is very close to our language than something that is in machine language, in an encrypted language, or some numbers or something. Okay, you won't remember me with my phone number, which is unique. Okay, but you will remember me with my name, right? That's how That's why we don't directly point out to the IP. We don't directly hit that IP. We hit it via a domain. Okay, so that's why a domain. Cool. So I'm hitting a lot of topics here. Don't worry about it. We'll discuss all of these topics at length when we'll be going ahead with the course. Okay, but I just want you to imagine stuff that we use every day. Okay, every day we go ahead and open Amazon.com, Flipkart.com, some other .coms. So we should understand what they mean. Okay, when we type Amazon.com, it's basically not an IP but a domain. Why it is a domain? Because it needs to recognize with people. I can remember Amazon.com, but I won't remember IP of an Amazon.com, right? And that IP might change, that server might change tomorrow. So I don't want to remember it, and then once it's changed, send it to my customer that okay, this IP has changed, go ahead and now hit this IP. We'll have a domain, you remember just the domain, and everything in the backend will be taken care of. So this becomes a black box for the customers. Okay, but since we are part of DevOps team, we understand this part as to what is happening in layers below. Okay, so now in previous times, when we like previous times as in some decades ago, okay, there was nothing called as a cloud, AWS, if you have heard of. Okay, there was nothing as cloud architecture. So infrastructure is a system or a machine. So companies used to buy these machines, okay, keep it in a server room or keep it in a room. Why we call it as a server room? Because it needs certain level of cooling and all of that, cooling, dust free, so that we can sustain those servers for a long time. We cannot just go ahead and take it, and it's of a higher capacity. So that's why we call it as servers or server rooms, and deploy these like do some virtualization, create some small systems from this big system or a big server. Okay, that's where VMware, Dell, and all of that come into picture. Okay, they will have so we have one big system. Okay, we'll use some VMware application to uh, make it into small fragments of systems. Okay, virtual systems. Okay, then we'll deploy our application on those systems and let the request routing happen the way I have explained it to be. Okay, before this virtualization, it used to be different servers only. Okay, so there used to be different physical servers that will be kept in the server room. People used to go there, manage that, and that's why system engineers and network engineers and other teams were required. Okay, they are still required. There are a lot of companies that they who still have a data center. Okay, and they keep their data, their customers data in the data center itself, so that it's safe because it's with them. Okay, they can understand, they can control everything, they can restrict people movement, etc. Okay, now then in the last few decades we have seen a rise or a sophisticated way of this servers. Okay, initially there's going to be like if we need 10 machines, then there's going to be 10 servers with X capacity or a higher capacity. Okay, now problem is that if tomorrow you want a new server in this kind of an architecture, you'll have to go ahead, buy it from probably a vendor. Your vendor will come, install it in the server room, and that's how systems used to happen. Okay, they used to have routers, switches, internet connection, everything is managed by you. So internet connection, electricity, router, switches, networks, systems, everything needs to be managed by you. Okay, that's called as a server room. Now big companies can go ahead and manage those on their own. Okay, because they have like lot of money, they can spend a lot of money. But now when times have changed, that there are new companies that are coming in, new there are new companies that are coming in. So initially setting up these servers, getting all these servers started, it is very difficult for a company to do a lot of this investment. Okay, because buying these servers, okay, and setting up their electricity, their internet backups, because you need your system to be 100% available, which means you have backups, you have your internet backup, you have your electricity backup, you need inverters, you need um, all of these things needs to be managed by you as a team. Now today, if you want to start a company and you have to do all of this, it will become a difficult entry point for you. Correct? You don't want to like, if all of this is going to take crores of rupees, okay, you don't want to spend all of that right now, okay, because if you would or had it in the first place, why are you doing all of that? Okay, or a person who already has it can actually do that, but it's again a risk. Okay, uh, a risk to, even before starting selling anything, you'll have to have this, all the systems. You'll have to have a network engineer, you'll have to have an engineer who is managing these also 24/7. Okay, so now it was a lot of cost, which is why there was something called as virtualization that came into picture. That means there used to be few servers, okay, and using virtualization, we used to like fragment those servers in multiple virtual machines, which means that they are system inside a system. Okay, they are virtually there, they are not physically there. It's like a virtual system that's there. Example VR, virtual reality. You watch you put a like, you put an instrument in front of your eyes and you start seeing something that's not there. Virtual. Okay, it's virtual, it's not real, but you kind of assume that that is happening. Okay, or it makes you feel that that's happening. Similarly, there is only one server or few servers. Okay, on that we can go ahead and make like approximately 3 4 servers based on the capacity of the server that you have. Okay, they will be a virtual machine. That is, it's not a physical unit, it's a logical unit. It's there, but it's not physically present. It's like, you'll see a RAM, you'll see an operating system, you'll see everything. Okay, we'll discuss this in length when we'll be starting Docker, and we'll discuss at length more about virtualization, but I'm like kind of helping you understand the evolution of infrastructure here. Okay, so first we discussed what an infrastructure is. Now we are studying evolution of an infrastructure. That means we first started discussing about having physical servers, server rooms, and all of that. Okay, and and now we are studying about virtualization. That means there is a server, there is a server room, but we are virtually building multiple machines from the same machine, so that you don't have to buy all of those machines. Okay, you can have few machines of a bigger capacity and set multiple systems in there, virtual systems in there. Okay, now this was basically done by companies like VMware, Dell. Okay, who used to give these services, but still again there was a need of having an infrastructure or buying an infrastructure means server. Okay, now comes a new era, that is cloud. Okay, wherein all of your cloud providers like AWS, Amazon Web Services, your Google Cloud Services, your Azure, your Ali Cloud, and others come here in this. Okay, now in this, they say you don't need to manage a server, you don't need to have a server room. We have a lot of server room, we have done all the investment. Okay, all you have to do is you have to come tell me, okay, that I need this server, this capacity, this much RAM, this much CPU, all of this, tell me, I'll make a server, give it to you. Okay, you do whatever you want to do with the service. The like, whatever time you want to use on that server, use it, and then you can like release that server, and you no longer have to pay for it. It is very similar to your own house. Okay, earlier, in like old age, everyone used to have their own house, everyone used to build their own house earlier. Like if you go, everyone will have their own house somewhere in their hometown and their village. Okay, why? Because there still people are more concerned of having their own house, having their own servers. Okay, when you will come to a suburban area, there used to be houses, but people used to rent some of that part. Okay, or have certain segments, sections, and all of that. That's virtualization. Now this cloud is basically where we live in. Sometimes you move to a separate, you move to a different city. Okay, you cannot have house in every city. Example, earlier I was working in Bangalore, now I'm working in Pune. I didn't buy a house there, I rented a house there. Till the time I have to live in that house, I am going to pay my uh, landlord in some X amount of rent. Okay, now when I'm leaving, I leave the house. That house remains with the landlord. I go. That's all. I come in Pune. I buy another place. I buy another like I rent another place by another landlord, and that's how I am living now. So from server where everyone used to have their own house, that building that house, okay, used to be a big affair for everyone. Okay, everyone wants to have their own house. Sometimes people used to build their own houses also. Example, they used to carry and build some infrastructures, build their own stuff, everything, like everything they used to do. Now in urban areas, what we do, we rent out the infrastructure because we don't know till when we are using it, and we don't want to put a lot of capital there. Okay, because we don't know, we want to just get started. A person who has just started working might not have their own house, might not have so much of money that I am moving to from Bangalore to Pune, I want to buy another house here now. No, we'll just go ahead. Okay, we have some money, we want to rent it out, use it till the time I'm using it, because I don't know whether I'll be for how long I'll be using it. Currently, when a new company is coming, they might not know what capacity, what like, since when you start, okay, you have X amount of customers. Okay, you don't know that those X amount of customer will become X plus Y, like X plus 5X, 10X, or will become X by 2. Okay, you don't know. There is a lot of variables here. Okay, so what we want to do is to get quickly started. Okay, we want to come, okay, buy servers from these landlords, that is AWS, GCP, and all of that. Okay, pay for the amount of servers, pay for the amount of resources or amount of resources that we are using from them, and that's it. That's all. That's cloud for you. So when somebody say cloud services, it's basically simply that. When you say cloud kitchen, there's no physical kitchen or there's no physical dining area that you can go to. You can just go ahead and order. Okay, so it's not in cloud. Okay, it's still there in on earth, land. Okay, but what happens is you don't go ahead and physically go ahead and visit that place. It's somewhere running it from some apartment, or it can be running it from a small area wherein you can just go ahead and take a takeaway. Okay, similarly, in our AWS environments, it's not our servers. Okay, it's AWS servers where everything is running. We just ask them to provision a machine for us using virtualization, whatever they do. I'll explain what they do also. But we just go ahead, tell them I need this. They'll make a machine, give me an IP. Using that IP, you can log into that system and work. That's how most of the companies are actually working these days, because it's a good entry point and you don't have an overhead of handling all of these things. Okay, similarly, when you go on a rented apartment or a rented place, you don't have to manage that place, you don't have to pay apart from your rent, you don't have to worry about the security, like there used to be a community money that goes in, then there is land tax, other tax, registration tax. You don't have to worry about all of that. All you have to worry about is just go ahead, pay rent, finish, live there, and once it's done, go. Okay, you although manage that place, right? When you live in a place, you'll manage that place, you'll manage the system, but you'll not go ahead and take care of all the rest of the things. Same way, when you bring up a service or a system in all of these cloud providers, you ask them to create a system for you. You go on that system, you manage that system, you deploy your applications, you install whatever you want to install, whatever you want to do, you can do on that system. Okay, that is managed by you now, something that's happening inside the system. But but where that server is, whether that server is getting electricity, internet, all of these things is not of your concern. You have to tell them ye chahiye, they'll make it for you. Okay, is it making any sense? I know that I'm making a lot of analogies, but I want you to visualize it in a way, because whatever we are doing in softwares, there is some or the other connection with the real world as well. So if you learn the connection, you don't have to learn everything. You don't have to learn what a server is, what a cloud is, or uh, uh, maybe a definition of what it is. Okay, all you should know is understand the core. Okay, so core concept is I'm renting a server, because why? I don't have enough money. I don't want to spend crores of my money in going ahead and buying a server and doing my testing on that. So what I'll do is I'll just a quick solution: go to a cloud provider, make a small amount account and pay them rent for the servers that we use. Okay, so this is infrastructure for you. Okay, now we started two things today. First is what is an infra. Second, evolution of infra. In evolution of infra, we studied more about data centers where all the servers and everything is kept. We have not uh, gone deep dive into what a data center is, how it is built, and all of that. Okay, but just consider it as servers. A place where all the servers are kept is called a data center. Okay, or server. Like there can be multiple server rooms in a data center. Okay, backups, everything, backup systems, all of that is there. Okay, then we studied about a bit about virtualization. I didn't go deep dive into that because it can be a lot overwhelming for you to understand that concept and visualize that. So a little bit of virtualization, wherein I told you that there are less servers, but but we can create some virtual machines. Machines as in there's no physical, they're not physically available. Okay, they're servers inside servers. Okay, um and then we studied about cloud and what a cloud architecture is. So any questions, anything specific that you would like to discuss?